Okay, lesson 25 is listing factors of whole numbers. So remember, a factor is a whole number that can divide a number with no remainder, or it's any number multiplied in a multiplication problem. Oops, I forgot to write problem. So if I have 3 times 4 equals 12, that's a factor, that's a factor. But if I'm thinking about the factors of a number, those are two numbers I can multiply together to get that number. So 3 and 4 are both factors of 12. Okay, so let's list the factors of 20. The book does it kind of differently. I'm going to show you two different ways that I can do it that makes sense to me. So let's think about factor pairs, because factors always come in pairs. You can't just say 3 and 12. 3 times 4 is 12. So let's do 20. You always do 1 and 20. Is 2 a factor? Yes. 2 and 10. What about 3? 3 won't go into 20 evenly without a remainder, will it? What about 4? Yes, 4 and 5. So 4 times 5. 6, 7, 8, 9, and I've already got 10, so I'm done. I've got all the factors of 20. Another way you can do this, and it kind of makes it easier when you're looking for your greatest common factor later on. I'm going to get the same numbers. I'm just going to do it slightly differently. So I'm going to say 1 and 20, 2 and 10. See, I'm writing, so I'm going to make a kind of like a alphabetical list. Alphabetical's the wrong word, but 4 and 5. So now I have a list in order from least to greatest. So I can either write them in pairs or I can do a list, right? Okay, so what about example 2 says list the factors of 23. Well, the only factors of 23 are 1 and 23. So it's actually a prime number. It means it only has a pair of factors, that 1 in itself. So I don't have any more factors of that, do I? So that's easy. What about example 3? That says, which of these numbers is not a factor of 30? So I can think about what I know about divisibility rules. So if it ends in 0, I know 10's a factor. If it ends in 0, I know 5's a factor. If it's an even number, I know that 2 is a factor. What about 4? I don't really know about that one. What about 3? So we didn't look at those divisibility rules. So let's just go ahead and write our factors out. And I'm going to go ahead and write them in pairs this time. So I always know that 1 and the number is a factor pair. And I know that that's an even, so I know it's going to be 2. And I know it's 15, because 15 is half of 30. What about 3? Oh, 3 times 10. What about 4? Let's see, let's come close. 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. So nope, 4 won't work. Let's chop that one out. What about 5? Oh, 5 and 6. 7, 8, 9, 10. I've already got 10, so I've got all my factors. So I know that 4 was the one that was not a factor of 30. Okay, what about example 4? Which factors of 9 are also factors of 18? So let's go ahead and write them out. I'm going to write this in a list form. So 1 and 9, 2, nope, 3. Now I'll go ahead and put another 3 there just for the sake of it. So 1 times 9 and 3 times 3. Any other factors? 4, 5, 6? Nope, that's it. Okay, so let's write the factors of 18. 1 and 18. That's an even number, so I know 2 and 9. What about 3? Oh yeah, 3 and 6. 4? Nope, because 4 times 16 and 4 times 4 is 16 and 4 times 5 is 20. 6 I already have, so I can stop. Okay, so there's a pair, there's a pair, and there's a pair. That one's just repeated. So all the factors of 9 are also factors of 18. Why is that? Because 9 is a factor of 18. Does that make sense? So if your number you're trying to find, if it's a factor and if it has the same factors, then you know all the factors of 9 will also be factors of 18. Now 18 has a couple more because it's a little bit bigger number, but 9 is one of the factors. So all the factors of 9 are also the factors of 18. I think I said that poorly. Hopefully that makes sense. May need to practice a little bit with that one. Does everybody understand how to write your factors out? This is where it really comes in handy to know your multiplication tables. So start working on those 7s and 8s. I know those are the hard ones, okay? All right, good luck.